what you see is a very clear pattern on the screen. You see sort of stripes, a stripe on the screen where you get lots of electrons, and then a stripe where you get very few or none, and then another stripe where you get lots, and then a stripe where you get very few or none, and then another stripe, and then very few or none. So you get this stripy pattern. That pattern is exactly the same pattern that you would get if you sent waves through the slit. Let's say water waves, any kind of waves. Then it's easy to understand, because what's happening then, and physicists knew this back in the 1700s, right, is that you can consider each slit as a source of new waves. And the waves come out, and waves have the property that they can interfere with each other. So you can get the peak of one wave arriving at the screen from one slit, and a trough of a wave arriving at the screen from another slit. And if everything's lined up correctly, the peak and the trough cancel out and you get nothing. So you get this property where something from each slit, it's very easy to understand if it's a big extended wavy thing, lines up in such a way that it cancels out. And then it could line up in such a way that it reinforces, and you get a big disturbance there, and then it cancels out again, and then it reinforces again. So you can imagine this stripy pattern on the screen.